All right, if you really want to get your head around Kubernetes, you've got to start in one place. And no, I'm not talking about deployments or services. Nope. We're going to the absolute core, the fundamental building block that everything else is built on. Today, we are demystifying the Kubernetes pod.
So let me just ask you this straight up. What do you think is the single most important, most fundamental building block in the entire Kubernetes universe? I mean, the one thing that if you took it away, the whole system would just fall apart.
All right, let's dive in and find out. The answer, as you'll see, is actually the smallest, most essential piece of the whole Kubernetes puzzle.
And here it is, the pod. Honestly, the best way to think about it is like the atom of Kubernetes. It is the smallest, most basic unit you can create and manage. You can't break it down any further. It doesn't matter if you're running a tiny little website or some massive complex system. Everything, and I mean everything, starts with a pod.
So what exactly is a pod then? The simplest way I've found to explain it is to think of it as a protective wrapper, kind of like a bubble. See, the pod itself isn't your application. Your app, your code, that lives in a container inside the pod. The pod's job is to provide this shared environment for one or more containers, giving them a common network, shared storage, everything they need to work together as a single cohesive unit.
Okay, so if the pod is the wrapper, what's actually inside it? Let's peel back a layer and take a look at the anatomy of a pod, see what really makes it tick. Really, it all comes down to one word: sharing. That's the whole reason pods exist. The containers inside a pod share some absolutely critical resources. For one, they get a single IP address and network space. This means they can talk to each other on localhost, just like they were processes on the same machine. Super handy. They can also share storage volumes. Think of it like a shared hard drive they can all read from and write to. And this last one is huge. They share a life cycle. They are born together and they die together. You can't stop one container without stopping the whole pod. And that's exactly why you only group containers together in a pod when they are super tightly coupled and need to live and die together.
Right, so that's the theory. But how do we go from this idea of a pod to actually having one running? Well, you need a blueprint. And in the world of Kubernetes, that blueprint is almost always a YAML file. So let's decode one of these blueprints and see what it's telling Kubernetes to do.
Now, instead of just throwing a wall of code at you, let's break it down piece by piece. First up, API version and kind. That's just you telling Kubernetes, hey, I want to use this version of the API, and the kind of thing I want to create is a pod. Simple enough. Then you have metadata. This is where you give your pod a unique name and maybe some labels so you can find it later. But the real magic, the heart of the whole thing, is the spec. This is where you lay it all out. Which containers to run, which Docker images to pull, what network ports they need, everything. This YAML file is literally the DNA for your pod.
Okay, enough theory. Theory is great, but let's actually make something happen. Let's get our hands a little dirty and take that blueprint we just talked about and bring a real pod to life.
And you know what? The workflow is actually pretty straightforward. First, you take your YAML file and you tell Kubernetes to apply it. That's it. Kubernetes takes that blueprint and goes and builds your pod. Next, you'll want to check on it, right? So you run kubectl get pods to verify that it's up and running. If you need to poke around inside, you can use kubectl exec to get a command prompt right inside one of the containers. And then, when you're all done with it, kubectl delete just cleans everything up for you. Apply, verify, access, delete. That's the basic loop.
Now, in a perfect world, everything would work on the first try. But, you know, we don't live in a perfect world. So what happens when your pod just doesn't start? Or it gets stuck? Let's go over a few of the most common issues and how to troubleshoot them.
Yeah, think of this as your troubleshooting first aid kit. If you see something like image pull backoff, 9 times out of 10, it means Kubernetes can't find the container image you specified. You probably just have a typo in the name or you're pointing to the wrong registry. Easy fix. Now, crash loop backoff is a bit different. This means the container is starting, but then it's immediately crashing for some reason. Your application has an error. Here, kubectl logs is your absolute best friend. It'll show you the output from your app so you can see what's wrong. And finally, if you see your pod just sitting there in a pending state forever, that usually means the cluster doesn't have enough CPU or memory to run it. The command kubectl describe pod will tell you exactly what's going on.
Okay, so let's just quickly recap the most important things to remember. First, pods are that atomic, indivisible unit of Kubernetes. You can't get smaller. Second, each pod gets its own unique IP address, and all the containers inside it share that network. But third, and this is probably the most critical thing to drill into your head, pods are ephemeral. They are not designed to last forever. Think of them like a light bulb. When it burns out, it's just gone. It does not fix itself.
And that leads to a really big question, doesn't it? If pods are so fragile and disposable, how on earth do we build reliable, self-healing applications with them? I mean, what happens when one just fails in the middle of the night? The secret, my friends, is that we don't manage pods directly. We use higher-level controllers to act as their managers, and that is exactly what we're going to dive into in our next explainer.